Hello students, today we'll complete part 3 of Unit 2 Solution, Class 12 Science. The topic we are going to cover today is Henry's Law, its mathematical expression and the application. Now, Henry's Law is a law that establishes a relationship between the partial pressure of a gas and its solubility in the solvent, liquid solvent especially. This is a law for gas-liquid solution. The statement of this law is, at constant temperature, the solubility of a gas in a liquid is directly proportional to the pressure of the gas. Another statement or mathematical expression that can be derived is, the partial pressure of the gas in vapor phase or vapor pressure P, it is proportional to the mole fraction of the gas denoted with X in the solution. That means partial pressure of the gas is directly proportional to the mole fraction of the gas in the solution. So here from the second statement we can derive the mathematical expression for Henry's law. So mathematically, partial pressure of the gas, that is P, is proportional to mole fraction. Now if you remove the proportionality sign, you get a constant, that is Kh. Kh is known as Henry's law constant. Now some fact about Kh values are, at a particular temperature different gases have different Kh values. This Kh value depends on the nature of the gas. At a given pressure, increasing value of Kh implies lower solubility of the gas. The second point is very important. You have to remember that if this pressure increases, then Kh value, if pressure is constant, the Kh value, if it is high, the solubility of the gas will be low. That means solubility and Kh is inversely proportional. Next, value of Kh increases with increase in temperature. So if Kh value increases, what happens? The solubility decreases. So Kh value increase with increase in temperature, and hence the solubility of the gas will decrease, or you can say the solubility of gas increases with decreasing temperature. That means at low temperature solubility of the gas will be more, and if you increase the temperature, then Kh value increases and solubility will be less. So due to this reason, cold water is more sustainable for aquatic life than warm water, because in warm water gas or oxygen have low solubility, so the oxygen will come out and the aquatic life will deprive of oxygen and they will suffer. Three important applications of Henry's law will discuss here. First one, in the packaging of the aerated beverage or cold drink or soda water, you can consider. Now what happened when we consider this cold drink? These are the carbonated drink where while in packaging the carbon dioxide is sealed under high pressure. The bottle is sealed with carbon dioxide under high pressure, so that more and more carbon dioxide get soluble in the liquid solvent. Now as soon as we remove the bottle, the gases have a tendency to come out, because the atmospheric pressure is lower, outside the pressure is lower than the inside pressure when you open the bottle. So this carbon dioxide gases come out rapidly in the form of effervescence. So we find a first application of Henry's law, that if we apply more pressure, we can dissolve more gas in the solvent to make a solution. Next, at high altitude, that means the mountaineer or climber, when they move to the high altitude, what happens? The pressure at the peak on the top of the mountain is very low. Now when the pressure is low, the solubility decreases, because pressure is directly proportional to solubility. So if pressure is low, solubility of the gas is also low. So at high altitude when the mountaineers go, then the oxygen solubility become less in the blood. In their blood, the oxygen do not get dissolved properly, and lack of oxygen causes uncomfortableness, then breathing problem. They cannot think properly. At that point they feel weak even, because without oxygen respiration will not complete, so they feel weak. So that state of the person is called anoxia. Okay, so what happened, you see here, the partial pressure of the oxygen at high altitude is less than the ground level. This result in low concentration of oxygen in the blood tissues of the people, and at this situation people can't think properly, and that state they feel weak, and that state is called anoxia. Third application or third explanation for Henry's law is in scuba diving. Now scuba diving is what? In scuba diving, the people, they go deep beneath the sea or ocean. Now when they go down the ocean, at the bottom of the ocean the pressure is very high, because when the person is moving down they are feeling the pressure of the water plus the pressure that is above water, the air pressure. So at the bottom the person will be under tremendous high pressure. At this point, if pressure is high, the solubility will be higher. So when they breathe, okay, when they breathe from breathe the air from their cylinder, then due to this high pressure more and more gas get dissolved in their blood, and in the cylinder they have the nitrogen gas. If they just have the air mixture, then they have high percentage of nitrogen. So this nitrogen, then oxygen, that get dissolved in their blood. You know that in air nitrogen percentage is more, okay, and nitrogen when get dissolved in the blood, it is not good for them because it is toxic. So more dissolving of nitrogen is not good. So that is one condition. Next, what happened if more nitrogen get dissolved in their blood at the when they are at the bottom of the sea? That result a critical condition for them. Now, how the critical condition arise? When they start moving back, okay, when they start going back to the to the land or to the terrestrial site, while moving upward, that dissolved nitrogen have a tendency to come out rapidly in the form of bubble. Okay, so in their blood, you can see here. So this is a person, this is a scuba diver. He is going down. As he is going down, more and more gas getting dissolved in his body, because pressure is very high, and at high pressure more gases have more solubility. So at this point what happened, his body is filled with the blood is filled with the nitrogen, okay, along with other gases, oxygen and other gases also. So that is one condition, that is a poisonous condition, not very good condition. So after reaching this condition, when he start going up, okay, then what happened, the pressure slowly decreases. Now as the pressure decreases, whatever solubility of the gas also decrease. So the gas that already get dissolved in the blood have a tendency to come out rapidly in the form of bubble. So the bubbles are created in the arteries, and it make the person feel tremendous pain. Okay, the person feel tremendous pain, even it is a life threatening situation. And this situation is called, or this disease is called the bend disease. So to prevent the bend disease, we can use Henry's law. Now how Henry's law help here? What is done, as we can understand why it happened, why what is the cause of this bend to happen, Henry's law help us to fill the cylinder of the scuba diver with a good proportion of gases, like helium gas is mixed there to dilute the air, to reduce the concentration of nitrogen in the cylinder. So in the cylinder, scuba divers carries oxygen gas 11%, nitrogen gas 58% instead of 78%, and it is being diluted with helium gas of 11%. Like that, the critical condition or medical emergency can be avoided. So Henry's law helped the scuba diver to work happily. So these three applications of Henry's law, these are very important. So you will surely remember or surely memorize the Henry's law, its mathematical expression and its three applications. This is very important topic. So that's all for today. Thank you.